Look under the hood of a modern performance car, any modern performance car, and you're going to find the same thing. A giant plastic cover, maybe some carbon fiber trim if you're lucky, a few strategic badges, and underneath all of that theater, an engine so complicated, so electronically neutered, so physically enormous that the engineers who designed it probably need a 3-day seminar just to explain what it does. And the manufacturers absolutely love this. They love it because complexity sells. They'll brag about quad overhead camshafts, variable valve timing on both the intake and exhaust sides, 48 sensors, 12 actuators, and a software stack that would embarrass a small aerospace company. And they'll charge you $100,000 for the privilege of owning something you can never actually fix yourself. Something that'll brick itself the moment a single sensor decides it's had enough. Now, don't get me wrong. The Ford Coyote is a brilliant piece of engineering. The BMW S62, the Audi 4.2 FSI, these are mechanical philosophy lectures. They're beautiful, they're intricate, the kind of engines that belong in a museum with velvet ropes around them. But they are also fragile, they are physically gigantic, and they represent a very specific kind of engineering arrogance. This idea that more is always better. That complexity equals sophistication. That if you're not using 4 camshafts, you're not really trying. Here's the thesis. In 2005, Chevrolet, almost entirely by accident, built the perfect V8. They didn't do it by chasing the latest technology. They didn't do it by adding 17 new features to a brochure. They did it by looking backward, stripping out everything that didn't need to be there, and concentrating pure physics into a package so modest, so unglamorous, that 99% of people drove right past it without a second glance. It wasn't in a Corvette, it wasn't in a Cadillac CT-SV, it was hidden in a 4-wheel drive work truck. And it was called the L33. To understand the L33, you need to understand where GM was in the early 2000s. The 1500 series trucks, your Silverados, your Sierras, they were selling well. Commercially, everything looked fine. But behind the scenes, the engineers had a problem. The 4-wheel drive extended cab variants were getting heavy. Transfer cases, reinforced frames, longer cabs, it all added up. And when you put one of these trucks on a dyno next to a Ford F-150, the numbers weren't flattering. GM was losing the horsepower war in the segment that paid the bills. They needed more power. They needed better fuel efficiency. And they had exactly zero budget for a clean sheet engine program. So the engineers did what engineers do when the accountants say no. They got creative. They raided the parts bin. Specifically, they raided the parts bin that held all the components GM had developed for their high-performance programs, the racing stuff, the Corvette stuff, and what they assembled was something that on paper should not have existed in a work truck. This is where the VIN code becomes important. If you're an enthusiast, if you've ever gone hunting for an L33, this is the secret handshake. You pop the hood, you find the VIN plate, and you look at the 8th digit. Most 5.3-liter Silverados and Sierras from this era will show you a letter Z. That's the LM7. Iron block, 5.3 liters, totally fine engine, reliable, heavy, nothing special. But if you find a truck with the letter B in that 8th position, you've just found something completely different. Most buyers had absolutely no idea. They walked into the dealership, they ticked the box for 4-wheel drive extended cab, they drove home in what looked like every other work truck on the road. And underneath that completely ordinary sheet metal was a disguised performance engine, one of the most underrated stealth packages in American automotive history. And the window to find one is insanely narrow. The L33 was only produced from 2005 to 2007, 3 model years. That's it. Then it was gone, replaced by the newer Gen 4 architecture across the board. If you blinked, you missed it. So, what exactly is hiding under that boring plastic Vortex cover? Start with the block. The L33 uses an aluminum block, not cast iron. Aluminum, the same casting architecture that went into the LS2. Now, you might think that's a small detail. It is not a small detail. It is a difference of 100 pounds, 45 kilograms, taken directly off the nose of the vehicle. Think about what that actually means. When you remove 100 pounds from over the front axle, you're not just making the truck lighter, you're fundamentally changing how it behaves. You're altering what engineers call the polar moment of inertia, where the mass sits relative to the center of rotation. The result is a truck that turns in more willingly, that reacts faster to steering inputs, that feels nimbler than its curb weight has any right to suggest. You've got a truck engine that behaves like it belongs in a mid-engine sports car. That's not marketing speak, that's just geometry. But the aluminum block is only the beginning. The real magic is in the cylinder heads. The L33 uses the 799 and 243 castings. If those numbers mean absolutely nothing to you, let me give you the context that will change how you see this engine. Those are not truck heads. Those are the exact same high-flow cylinder heads from the C5 Z06 Corvette, derived directly from the LS6. The same heads that sat on top of one of the most celebrated American performance engines of the modern era. D-shaped exhaust ports for maximum flow, massive intake valves, port geometry that was designed for one thing and one thing only, moving as much air as physically possible. Chevrolet fitted Corvette Z06 heads to a work truck. Just let that sit for a second. Z06 heads on a Silverado. And then they went even further. Most of the lower spec 5.3 liter engines use dish pistons to keep the compression ratio safe and conservative. The L33 got flat top pistons instead. That one change bumped the compression ratio up to 9.9 to 1. Not crazy high by modern turbo standards, but for a naturally aspirated truck engine in 2005, that's aggressive. High compression means more efficient combustion. More efficient combustion means more power and better fuel economy at the same time, which, if you remember, was exactly what GM's engineers were chasing in the first place. So what you've got hidden under a plastic cover with the word Vortex stamped on it is a high compression, high flow, lightweight aluminum V8 with literal Corvette DNA. It's not a truck engine pretending to be a performance engine. It's a performance engine wearing a disguise. Now we need to talk about the argument that nobody building six-figure European sports cars wants to have. The Ford Coyote is a genuinely remarkable engine. 5 liters, dual overhead cams on both banks, variable cam phasing, 32 valves, TIVCT, the whole works. It makes incredible power. It sounds phenomenal. And if engineering were purely about technical achievement on a spec sheet, the Coyote would win every single conversation. But engineering is not about spec sheets. Engineering is about solving problems in the real world. And the Coyote has a problem that the brochure will never tell you about. It is physically gigantic. We're talking nearly 30 inches wide. The twin cam architecture means the cylinder heads have to extend way out over the sides of the block, the cam covers sit high, the engine occupies space in literally every direction. It's a brilliant piece of machinery, but it's also a packaging nightmare. The L33, the Pushrod engine, the allegedly outdated technology, the design that everyone says GM should have abandoned decades ago is roughly 20 inches wide, 10 inches narrower than the Coyote. That is not a rounding error. That is not a minor detail you can ignore. That is the fundamental difference between an engine that fits cleanly into a chassis, and an engine that forces you to redesign the entire front end around its requirements. What does that mean for someone actually building a car? It means the L33 lets you keep your shock towers exactly where the factory put them. Your steering rack doesn't need to move. Your firewall stays where it is. Your brake master cylinder doesn't get relocated. You can drop this engine into basically any rear-wheel drive platform ever built, and it'll sit lower, it'll sit further back towards the firewall for better weight distribution, and you'll still have room to work on it without removing half the front suspension. The pushrod design isn't old technology. The pushrod design is compact intelligence. You've got 2 camshafts instead of 4. No massive cam towers hanging off the sides. No ridiculously complex valvetrain architecture stretching across the entire top of the engine. And here's the thing, every component that doesn't exist is a component that can't fail, can't add weight, and can't steal space from something more useful. Chevy didn't use this architecture because they couldn't afford to build something more complicated. They used it because they understood something the European manufacturers had completely forgotten. The best engineering solution solves the problem in the smallest possible package. Period. Now here's where the conversation stops being about history and starts being about what this engine will actually do when you stop being polite with it. The L33, as part of the Gen 3 transitional architecture into Gen 4, got upgraded internals compared to the earlier 5.3-liter variants. Specifically, the connecting rods got beefed up, stronger, designed to handle loads that a work truck will literally never apply to them, but that a builder chasing serious power absolutely will. The wrist pins float, which cuts friction, reduces wear, and extends the engine's tolerance for outright abuse. Now here's the technical argument that changes everything if you're trying to decide between a 5.3, a 6.0, or a 6.2-liter block for a high boost application. The 5.3-liter block has thicker cylinder walls. The bore is smaller. And when you're forcing compressed air into a cylinder, when you're running a turbo or a supercharger and cramming way more air and fuel into that combustion chamber than it was ever designed to handle. The structural integrity of those cylinder walls is the only thing standing between you and a catastrophic failure. A grenaded block. Game over. Thicker walls mean you can run more boost. More boost means more power. The smaller displacement of the 5.3 isn't a limitation. It's a structural advantage. Let me put real numbers on this so you understand what we're actually talking about. A used L33 out of a salvage yard completely running, low miles because it came out of a truck, costs about $1,200. A decent single turbo setup, nothing crazy, just a quality unit with the basic supporting hardware, adds maybe $600. Throw in a weekend of your time for fabrication and tuning, some injectors, a fuel pump, an ECU reflash, and you're looking at a total investment somewhere south of $3,000. That combination, when done properly, will produce enough power to absolutely humiliate a $200,000 Ferrari in a straight line. This is not a hypothetical. This is not a best case Dino Queen scenario. This is math. This is what happens when you take proven high flow cylinder heads, high compression, and aluminum block and forced induction, and you combine them in a package that was engineered from day one with structural robustness as the priority. You get an engine that was accidentally overbuilt for the application it was sold in, which means it has headroom that most dedicated performance engines never get close to. It's not just fast, it's an insult. It's a direct insult to every manufacturer who has ever charged $100,000 for complexity theater and called it engineering. The L33 is not just some obscure engine from a short production run that only collectors care about. It's a statement. It's proof. It's the clearest possible evidence that the engineering philosophy of the last 20 years, the philosophy that says more camshafts, more valves, more electronic intervention, more physical size equals better performance, is fundamentally a lie. A lie that costs you more money, produces less reliable results, and fills up your engine bay with components that exist to justify a price tag rather than solve an actual problem. The L33 was built to solve a problem. It was built under brutal budget constraints. It was hidden in a truck that nobody was paying attention to, and it quietly, without any fanfare, assembled a combination of lightweight construction, high compression efficiency, high flow cylinder heads, and structural toughness that most dedicated performance engines never managed to achieve all at the same time. Ford built a watch. An incredibly complicated, beautifully intricate watch. Chevrolet built a sledgehammer that also happens to tell the time more accurately. And the lesson the L33 teaches, the lesson every great piece of engineering teaches, is that history doesn't remember the most complex solution. History remembers the one that won. Are you a disciple of quad-cam complexity? Or have you seen the light of the L33? Let us know in the comments. You'll find us here every single week. And on that bombshell, this is 4 Wheels and Fuel. See you next time.